Good morning, students. So in the previous class we are discussing about halogenated compounds in that chemical properties. So 6 chemical properties are over. Next the special feature. So that is nucleophilic substitution reaction. So we are seeing in that some compounds also completed. I think so with hydrogen H minus. So where you will get lithium hydride, sodium hydride, otherwise lithium aluminium hydride, otherwise NaBH4. So these all compounds are supplying H minus. So that we see. Next, second, RLi, RMGH. So Grignard reagent with alkyl halide we are completed this one. Next, so third. See, alkyl halide treated with sodium acetylide. So any negative. So you treated with this. So nucleophile is coming, another nucleophile is going. So you are getting CH3, CH2, C triple bond, CH. So sodium acetylide, so negative charge. Next, fourth, CH3, CH2, Cl. So treated with sodium ethoxide. So here also the negative charge is coming, Cl will be eliminated. So your answer is CH3, CH2, O. CH2, CH. So you are getting ether. So sodium ethoxide or alkoxide. So any negative that is readily reactive with alkyl halides. So next you take a carboxylate. So fifth, you take a CH3, CH2, Cl. You treat it with sodium acetate. So sodium acetate, nucleophile is coming, another nucleophile is going. So you are getting CH3, CH2, O. CO, CH3. So you are getting ester. Next. So another. So important. So you take NaCl or KCl, CH3, CH2, Cl. So you take NaCl. So Na plus C triple bond N minus. But here 2 members are there, nucleophile. So NaCN or potassium cyanide, this has ionic nature. So ionic nature means a carbon here gets a negative charge, this is a lone pair. So here the ionic nature, so ion is more powerful. So you are getting CH3, CH2, Cl is the major product. Next, CH3, CH2. This is also nucleophile, so that is also connected. So NC, isocyanide is minor. So between sodium and cyanide you have ionic nature. So negative charge is more powerful. Suppose instead of sodium you take silver. So silver is nothing but D black element. So nearer to pseudo-octet configuration. So that means that it has a covalent character. So CH3, CH2, Cl. So that is stated with the silver cyanide. So AgCl. So here between so metal and carbon you have covalent bond. So that's why carbon is not connected. So now what happens? Lone pair. Lone pair is coming. So it will be going outside. So you are getting CH3, CH2, NC. Isocyanide is the major product. See the difference. NaCN, ionic nature, cyanide is major. So AgCN, covalent character. So lone pair only participated. So cyanide is a minor product. So in entrance point of view, so these are the important terms. Next, in similar manner, seventh one is also. So instead of this cyanide, so nitro and nitrite compounds. Suppose alkyl halide treated with sodium nitrite, CH3, CH2, Cl. So treated with sodium nitrite. So O minus N double bond O. So nitrogen also lone pair. Here two members are there, but sodium and oxygen between you have ionic nature. So here full negative charge. This is more powerful. So here Cl will be eliminated. So your major product is CH3, CH2, ONO. So that is ethyl nitrite. Ethyl nitrite is a major product. So minor, lone pair is connected. So CH3, CH2, N double bond. This is a minor product. Suppose in the same thing, instead of sodium, you take silver. So then what happens? So silver is there means automatically you must remember it is nearer to pseudo-octet configuration. So according to Fajan rules, so it is showing the covalent character. So you take CH3, CH2, Cl. So treated with this silver nitrate, AgO, N double bond O. See between silver and oxygen, so you have covalent character. So that's why remaining is nucleophile. More powerful is the lone pair only. So the lone pair is coming and this will be going outside. So you are getting CH3, CH2, NO2 is the major product. Next, ONO, nitrite is a minor product. So these last two are very, very important. So in examination, entrance point. Next time. So other than this negative, so neutral also. So you can take with the neutral. So ammonia, the neutral compound is the best one is ammonia. See, alkyl halide, CH3Cl. So treated with ammonia. So see, suppose ammonia you take excess. See, ammonia we are taking excess, then what happens? So all alkyl halide react with ammonia. So you are getting CH3, NH2. So primary plus H and Cl. HCl will be eliminated. You are getting primary amides. Suppose instead of ammonia excess, if you take alkyl halide is excess. So then what happens? CH3Cl. So now we are taking this is excess. So treated with ammonia. So the lone pair is coming, HCl is eliminated. So you are getting primary amine. So So you are getting primary amine. So now alkyl halide is excess. So that's why one more alkyl halide. Lone pair is coming, Cl is going. So minus HCl. So CH3, NCH3. Next, one more alkyl halide. So the lone pair is connected. So you are getting minus HCl. So CH3, N, CH3, CH3. Lone pair. Again, one more CH3, Cl. So the lone pair is coming and connected. So here you are getting the secondary amine. This is tertiary amine. So now again it is reacted. So nitrogen surrounded with 4 carbons. So lone pair is donated. So plus Cl minus. So you are getting a quaternary ammonium salt. So if alkyl halide you are taking excess means you are getting primary amine, secondary amine, tertiary amine, quaternary ammonium salt also. So in this the separation of amines. So actually in your amines chapter again it is coming. So in that the separation of amines are important. So what are the process? How to separate the amines? See, separation of amines. So what is that? See, to remember that easy one, Hinz BSc of DEO. So that is Hinzberg method. So Hinzberg's method. So what is the reagent? So benzene sulfonyl chloride. So by using benzene sulfonyl chloride, we are separating amines, all primary, secondary, tertiary. This is called as Hinzberg method. Next, the second one is Hoffman's method. So Hoffman's method, that is diethyl oxalate. So diethyl oxalate, direct questions. What is the Hinzberg reagent? What is the Hoffman's reagent? By using which method the amines are separated? So when you are getting amines all together, excess of alkyl halide or excess of ammonia, like that they can form. So many questions. So in NSR reactions, one more important point that is unimolecular nucleophilic substitution. So that is SN1. And another one SN2. So bimolecular nucleophilic substitution. So now we are going to discuss about that too. So in SN1 reaction where it is happening, in SN2 where it is happening. So what is the stereochemistry of SN1 and SN2? Also they are asking questions. So I think already we discussed nucleophilic substitutions are we seen 3. SN1, SN2, SNI. So SNI is observed in alcohols chapter. SN1 and SN2 is observed in alkyl halides. So now we are discussing about SN1. So that is unimolecular nucleophilic substitution reaction. So where it is happened? So it is observed in tertiary alkyl halide. So it is observed tertiary alkyl halide in the presence of aqueous KOH. So that is what? Weak base. So aqueous KOH is a weak base. Suppose you take CH3, 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 Cl. So treated with aqueous KOH. So your answer is CH3, CH3, CH3. Cl is replaced with OH plus KCl. So the progress of reaction is explained through the mechanism. So mechanism, step 1. So step 1, you take aqueous KOH is become as K plus OH minus. So it is fastly dissociated in the water. The OH minus is surrounded with water. So this power is decreases. So that's why you call it as a weak base. So the weak base is doing what? Just substitution only. It is participated. Next, step 2. So in step 2, you take CH3, 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 Cl. So here, 3 members are donating groups. So that's why chlorine is coming outside. So 3 plus inductive groups. So you can take hyperconjugations also. So that is eliminated. So bond is breaking. Bond breaking takes place at slow rate. So in any step of mechanism, anyone is moving with a slow rate. That is called as rate determining step. In rate determining step, how many reactants are participated? So that's why that number only you call as molecularity. So molecularity is 1. So you are getting CH3, CH3, CH3 positive and Cl minus. So complete positive you are getting. So this is a tertiary carbocation. So stable. So this is a stable intermediate. So here positive charge is coming. So that's why it has a polar nature. So it has a polar nature. So it is favored in polar protic solvent. So this reaction is favored in polar protic solvent. So these are important. Next, step 3. So step 3, what happens? So that tertiary alkyl halide. So tertiary alkyl halide react with Cl minus. So reaction fastly takes place. So you are getting a tertiary alkyl halide. Next, K plus attracted with Cl minus. So fastly reaction takes place. You are getting a KCl. So this is the mechanism of a step by step. Suppose the stereochemistry. So here the important stereochemistry also. So stereochemistry of SN1. So stereochemistry means optical nature. So you take 4 different groups. So carbon is central. We are taken R1, R2, R3 with the chlorine. So treated with so directly. So 3 members are donors. So what happens? 3 members are donors means carbon. You are getting R1, R2, R3 carbocation. So carbocation is the intermediate. So what is the hybridization of the central carbocation? See, the carbon is surrounded with 3 sigma bonds. So that means that the structure hybridization is sp2. The structure is trigonal planar. Bond angle is 120. So that is looking like this. So middle carbon plus 3 are there. So like that. So now here the chlorine is connected. So the chlorine is connected in what way? It is coming on the above side also, otherwise coming down also. So you are getting 2 products. R1, R2, R3 of chlorine. Next, carbon R1, R2, R3. See, suppose starting you are taken dextrorotatory, so you are getting a dextro compound also and levo compound also. So that means, so positive you are taken, positive only coming. So that is called as a retention product. Next you are taken dextro compound, you are coming a levo compound. So that's why it is called as inversion product. So what about these two? Both are mirror images. Non-superimposable mirror images. So that's why these two are called as enantiomers. So equal possibility, either top also, bottom also, 50-50 possibility. So that's why this is also called as racemic mixture. So the stereochemistry of SN1 gives retention and inversion products. It is forming as a racemic product. Racemic mixture that is optically inactive due to external compensation of their opposite rotations. So whatever we discussed, all you write down at one place. So that is the better for our entrance point of view. So where it is forming, in the presence of which reagent it is forming, so that everything. See, the SN1 so is forming in tertiary alkyl halides in the presence of aqueous KO. So in RDS, in the rate determining step, reaction rate is directly proportional to tertiary alkyl halide. So that's why molecularity is 1. Next. So here intermediate, carbocation intermediate. So it has a polar nature. So it has polar nature. Next, it is favored in polar protic solvent. So in the stereochemistry, you are getting retention product also, inversion product also. Next, racemic mixture. So where SN1 is forming? So SN1 is forming when tertiary carbocation is highest than secondary carbocation is highest primary carbocation CH3+. The order of SN1. So this is up to CAT only. So otherwise you can take tertiary carbocation is greater than benzene CH2+. So this is also in a NEET and JEE, that is important. So these are the important features of SN1.